Okay, I'm going to be working some problems for you from section 5.2. I'm sorry, 3.2. So the first question here is how to find the sample variance. So you can use the formula, and I use tutor. The correct answer is 88, but I'm going to show you how to do this in RGuru. So I'm in RGuru, and I went to data import and then create new data set, and I pressed this button for 7 values and input those values in for variable 1. And then I went ahead and saved it as 5.21. And then what I'll do is I'll go into functions, summary statistics. I'll select 5.21. And then they named that variable here as variable 1. And then all I really need is the variance. So you can undo the rest of these or just print it, doesn't matter. And then press your I. And there is the variance, 88. And as you can see, the correct answer here is 88. If you press the solution button, it will take you through how to hand calculate that. The next question asks for the sample standard deviation. And so again, I can use the same process. In fact, I could get the variance and the standard deviation in one fell swoop on RGuru. So let's go back there. If I go back and do summary statistics again on that same data set, this was 5.21, and select variable 1. This time I'll select standard deviation and variance. Click all observations. Now I get 9.3808 with a variance of 88. Notice they rounded the correct answer to 9.4. The range is the maximum value minus the minimum value. So I won't do that problem, but it would be your maximum value looks to be 5 and your minimum would be -14. So you would take 5 minus a -14, and you can use your calculator on that. So to calculate this sample variance, you would do the same process that I just showed you. You would create your table and then use your summary statistics. So according to Chebyshev's theorem, 75% of your data are going to fall within 2 standard deviations of the mean. And then 88.9% of the data will lie within 3 standard deviations of the mean. So let's figure this out using the information that's given to us here. We have a mean of 3.91 and a standard deviation of 0.32. So one way to do this is just to add and subtract 1 standard deviation. So I'm taking 3.91 and I'm adding, so you get 4.04, and then I'm going to add another one. So if I add another standard deviation, that's 4.17. So notice that's the value they're asking about. Okay, if I subtract one more standard deviation, actually I got to subtract the first one. So I'm going to go 3.91 minus 0.13, and that's 3.78. And then minus 0.13 again, that's 3.65. So this is 2 standard deviations below the mean, and this is 2 standard deviations above the mean. And according to Chebyshev's, that's 75% of the data will fall between +2 and -2 standard deviations of the mean. Okay, so for this question, it was asking for the coefficient of variation for two data sets, data set A and data set B. Data set A had 14 data values, and then data set B had 11. And so I went into our Guru and created a table, and I'll switch over to that. Okay, so again, you go to data import, create new data set, and that's what I did here. And then I just used these two buttons to create 2 columns and then 14 rows. In variable 1, I put A. In variable 2, I put B data. Okay, so you don't have to rename those. And then I saved it as 3.24. Then what I did was I went into functions, summary statistic, and I picked my data set 3.24. I decided to work on variable 1 first. That was the A. And then the coefficient of variation is your standard deviation to your mean. So all I need for those is the standard deviation and the mean. And then let me annotate here. Basically, you turn that ratio into a percentage. So we would, to get our coefficient of variation, we would take 0.50122 to the mean. And when you do that on your calculator, you get 0.1274, and that is 12.7%, because we just moved the decimal to the right 2 places. Okay, so that's the first coefficient of variation. I'm going to clear that though. So remember that A was 12.7%. Now we're going to go in and also run the summary statistic on variable 2. So 3.24 variable 2. Again, all I need is the standard deviation and the mean. So the coefficient of variation is 2.8282 to 54.809. And that's 0.0516 or 5.2%. So B would have the lower amount of variation as compared to its mean. So this was just asking to compute the various levels of, or the CV for both data sets. So the next question was which data set had the larger spread? And that would be the one with the higher CV, which would be the data set A. So those values are more spread out among the mean than data set B. So this question 5 has to do with the empirical rule, which states that 68% of your data is going to fall within plus or minus 1 standard deviation of the mean. 95% will fall within 2 standard deviations of the mean, and 99.7% will fall within 3 standard deviations of the mean. So I always like to draw this out. So we have a mean of 96 and then a standard deviation of 13. So where that kind of changes, goes from concave down to concave up, that is where the standard deviation is. So if we add 13, you get 109. So that's plus 1 standard deviation, and then we'll add another. That's 122, and then 3 standard deviations. If I add 13 more, you get 135. So going the opposite way, I'm going to subtract 13. So I get 83. and then 70. So, and that's 57. So really what this is asking, and this should be like this, no more than 57 means maximum 57. So it's really asking for this area out here. So let's talk about this area. 68% of your data will fall within this interval here. That's plus or minus 1 standard deviation below the mean. And then 95% will fall between plus or minus 2 standard deviations. And then that, so plus or minus 3 is going to be 99.7. So really, the rest of the data is going to fall out here. So we could take the 100% minus the 99.7. That's 0.3, not 30%, but 0.3%. And then if we divide that in half, because half's going to fall out here and half's going to fall out here, then we get the 0.15%, and that's your answer. So in this area right here, it's just 0.15% of your data. Let me clear this. So for this question, notice they're asking for the population variance and population standard deviation and the range. So when they say population, what they mean is that all the values, that's all from the population. You're not taking a sample to estimate a population. And so the formula for that changes. You divide by n instead of n minus 1. And I can show you on RGuru how to calculate that. But notice for our data set here, there's 10 fours. There is no variation whatsoever. Okay, so the range would be the max minus the min. 4 minus 4 is 0. The population variance would be 0 because there's no differentiation from your mean. Your mean is going to be 4. And then every value is 4. So population variance is 0, and so is your standard deviation. Okay, so now they give us another data set that is more varied, and they're asking us to calculate the range, the population variance, and the population standard deviation. So there are, I don't know if there's 10 values, but we want to go to RGuru. The range is your max minus your min, so that's going to be 40 minus 5, which is 35. But let's go to RGuru and calculate the rest. So I'm in RGuru, and I entered those data values here. Again, you would go to data import, create new data set, and then I just pressed this button 10 times. Okay, and I saved it as 3.27. So now in order to do population standard deviation, population variance, what you want to do is come down to analysis and go to summarization. And then we'll select that data set 3.27. Summary 1 is chosen, and then I'm going to choose variable 1. I'm going to hit univariate, and then I want the population variance and population standard deviation, and then press the I. And there are your answers. And I could have pressed the range too. That's 35, but it's 94.5 and then 9.7. So in this data set, you would do the exact same thing. You would create a table and then use the univariate analysis tools. Okay, so for this question, it has to do with the empirical rule. I'm going to draw this. We have a bell-shaped distribution again with a mean of 2.62. Standard deviation of 0.43, so I'm going to add 0.43. That gets me to my first standard deviation of 3.05, and then I'm going to add it again. That's 3.48. So this is +1 standard deviation. Again, 90 or 68% of our data is going to fall between plus or minus 1. So if I go the other way and subtract 0.43, this is 2.19. And then if I do it again, subtract 0.43, 1.76. So 95% of my data will fall, plus or minus 2 standard deviations. So outside of that is going to be 100% minus 95%, which is 5%. And that is both of these, this area out here. So I need to divide that in half to get just the right-hand side, because at least 3.48 is 3.48 or more. So that is the 2.5%. So is it possible to have a standard deviation of 435,000? Yes, it is possible to have a standard deviation that large. Standard deviation can be any value greater than or equal to 0. It can't be negative though, because remember the formula requires us to square, to take the variance, which is a squared measurement, and then take the square root. So in this question, it's asking about a bell-shaped distribution, again, using the empirical rule. So the mean is 8.47 and the standard deviation is 1.5. So I drew, I'm getting sloppier and sloppier, but this is 1 standard deviation and this is 2. I just added 1.5 each time. And if I went down this way, remember that 95% of our data is within 2 standard deviations from the mean. So it's asking for less than 11.7 or 11.47. So it's really asking for this area here. And if you recall, the area outside of 2 standard deviations, we just did a problem like that. We went 100 minus 95 divided by 2. That's this area is 2.5. And so the rest of that, if we took 100% minus 2.5%, that gives you the 97.5, which is the correct answer. So this area is 97.5%. Because the total area under the curve has to be 100%. I did a previous video on how to do something like this. You would use summary statistics after inputting all that data. And this, you would need to choose summary or sample. It wouldn't be population. So see my other video for that problem. And then I think you can use the empirical rule for this. Let me know if you have any questions on that one. And then we're looking at stock prices and comparing which one would be a more stable long-term investment. And so the standard deviation of the Azure is a lot less than the standard deviation of perfect plungers. So we would want to choose the Azure because the smaller standard deviation has less variability. And that is it for section 3.2.